I would like to explain experiment number 5, classic problems of synchronization using semaphores in OS. First, we define a weight, find, then we use if equals to empty, then global empty, then we use elif, find equal to mutex, then global mutex minus mutex subtraction or equals to 1 elif, find equals to full, then global, then full. If we define signal, find in same process, then you define in variable n equal to int input error buffer size buffer equal to mutex 1 empty, and then full 0 using while loop. Then print the statements: produce, consume, and exit. Then choice, enter your choice. Use if choice equals to 1, if mutex equals to 1, then empty equals to 0. Then print, enter the value and wait empty. Then print and enter the value, wait empty. Then print the buffer append int signal, else print buffer is full. If choice equals to, if full greater than 0, mutex equal to 1, wait full. Then print consumed value is string buffer pop, then signal empty, else print buffer is empty, else choice equals to 3, break. Then print, enter the invalid input, enter the buffer size 2, size 2, enter your choice 1, value 2, choice, then exit. And another program, reader process, then second problem, reader process. For random we use import shuffle choice, then global we define wait and if function, find equals to empty, do it as in the before. Then define signal and def readers equals to read equals to count, wait mutex read equals to count plus equals to 1, if read may read count equals to 1. Then wait writer signal mutex, then global count to the index, then print reader plus string index plus read control hash plus string count. If we use if loop, read count equals to 0, then signal writer, there signal mutex, then define writers, wait writer global count equals to index, then count equals to 2, print writer string modified content, string count index plus, then signal writer mutex write equals to count plus count equals to index plus read. Then for the I in range 15, choice is fns, then it modified content is 2, read content 2, read content 2, modified content a 4, 8, read 4, 8, 8, 16, 32, 64, 128, then modified content to 256, 12. Then third program, from random import global a, define wait process, signal process, enter a equals to 1, print allow philosopher to eat at a time using while loop, I equals to 0, process numbers is 1 to 4, copy 1 to process numbers, p equals to input 1 can eat, 2 can eat at a time. Then 3 exit, we using while loop I less than 5, randomly process, we print p dot string and other signal random processor plus 1 processor I plus, then increments to 1 if less than process number equals to 0, and break elif p equals to 2 and comes to elif p equals to 3, elif p equals to 0 while using j loop j less than prime and print the three values and the signal, then copy one dot, remove random process to j plus 1 equals to 1. If length copy equals to 1, elif p equals to 3 and break 1. P0 is granted to eat, P1 is waiting for eating, granted to eat, waiting, P2 and P1 is waiting, then P1 and P3 are granted to eat, P4 is waiting, P0 is waiting, P2 and P4 are granted to eat, and P4 is P0, P1 is waiting, P0 and P2 generated, granted, then P3 is waiting. Hence, implemented writers, producer, consumer, dining philosopher is